make a base. I'm going to call this base debug info. Okay, that's swanky and swell. Let's dive inside of that and let's make a few things. First up, let's go ahead and start by making a text top. So we can go ahead and grab a text top, dump it here in our network. This text top is going to be useful for showing our blueprint text. Okay, we'll see what we're up to here in just one second. First things first, let's make sure that we match the scale of this to our grandparent. So on the common page, under the resolution, or excuse me, under the output resolution, let's do a parent panel size. So a base doesn't have a panel that's associated with it, so we bump up the next layer to our container, which is our grandparent, but it's the first parent in line that has a panel. That's where we get that information from. That's swell. Okay, what do I want the text to be? I want the text to be parent to grandparent, right? Not just my parent, not the base, but my grandparent, base 2, dot par, dot blueprint type. This goober right here, right? My blueprint type is the text I want to have show up. I also need to make sure that I turn on this little blue flag, right? That I pull that information down in here. And you might be saying, hey Matt, why don't you just make that, why don't you just use bindings for this? Like, shouldn't it be the same on the top and the bottom, the way that we're binding all of things these days? Well, in this case, I'm not using bindings because I don't want this information to be bidirectional. I don't want to change, I shouldn't ever think about changing the text for this deep down inside my network. I should only think about changing it here at the top level. We could say that's probably true for lots of these parameters. But here especially, right, I have this parameter that's read only. I don't want to push values back up to it. I don't want to be in that habit. I want to think about only pulling things down from it. So there's some stylistic choices about, is it expressions? Is it bindings? Is it exports? In this case, the kind of principle that I'm working from is that I don't ever want to think about changing this one inside my network. I'm only retrieving information to drive this particular goober. Okay. Whew. Next things to do here. Okay, well, I also want to make sure that I change this font size. It's looking, could be just like a little bigger. I wouldn't mind if it was like 100, not 1000. That's crazy. 100. That looks a little too big. What's going on? Oh, well, I'm only 400 by 300. Here, my grandparent, let's go ahead and just change this to 1280 by 720. That looks a little more realistic. You might still have situations where you're working with sizes on outputs that are really small and tiny. And you could always use the auto fit if too large, right? So we could here, if we went back down to 400 by 300, if it wasn't going to fit in here, it would just auto fit to the most reasonable font size that's going to fit inside of our boundaries here. Your call on whether or not you want to do that. I'm going to go ahead and leave this at 1280 by 720. Seems like a reasonable assumption that I might make. Okay. I'm also, while I'm at it, I'm going to bump up the position of this just a little bit. I don't want the position of my text to be quite so in the middle here. I want to just like scooch it up, I think probably right around like let's say 225. That looks good. I want to have it live way up at the top there. Next things is I want this toggle, this blueprint text on off. I want that to drive the alpha of this goober. Now similarly, I only want to pull values down. I don't want this one to be bidirectional. So here on the color page, on my font alpha, right? If we run the slider on that, we can see that's driving the alpha here. So this is going to be my parent dot par dot, what do we call it? Blueprint text. Womp womp. Oh, because it's my parent 2. Remember, it's not just my parent, this one, it's my grandparent that I'm looking at. Okay, parent 2.par.blueprint text. So I should be able to turn that on or off and hide or reveal this particular piece here. I'm going to go ahead and leave that on for now. Okay, next up, let's connect a rectangle. Now this is what's going to represent the bounds of our output. Now, why do this? And I can only tell you that from the experience of having lots of projectors overlapping one another, it's often very helpful to know where one projector begins and another projector ends. And that's what we're up to here. One of the core ideas for that is that here in the size, rather than using fraction aspect, we want to use just fraction. And I'm going to turn this up to 1 by 1. It's going to fill everything laterally, everything vertically. Next up, my fill alpha is going to go down to 0. I don't care about filling this rectangle. I do, however, care about a border width. This is a diffraction, so let's just, find something that's right for us. Now, you can noodle around with this. You might well find that you have a very particular number of pixels that you want to work with, right? Especially if you're working in with LED walls, you might want to know that your borders are exactly 25 pixels so that if something is shifted left or right, up or down, you could go and count the number of LEDs to figure out what's going on there. I'm not going to worry about that here. I think I'm just going to go ahead and live with this 0.25 size. Now this time around for my border color, this time I am going to use bindings. And you're going to say, Matt, you just broke the rule that you told us about. Why? Why on earth would you break this thing where you used to be able to, in some cases you're not letting us change it, and in this case we are using bindings? Like, I don't get it. Well, let's do this for a second and see why we might care about this. Okay. So here, let's write an expression for this. Parent, this is my two, grandparent dot par dot border color R. I believe that's right. Let's check. Yeah, border color R. Rad. Let's borrow that again, because we're going to have border color G and border color B. Now, the reason this one's a binding is that, especially with color parameters, it is often far more useful to be able to change this one in multiple places than to only change it in one place. Because you've got 3 different parameters that you're connected to, and there's a good chance that you're going to noodle with this one a lot more. You might want to shift a color just a little tiny bit, and you happen to have this portion of your network open, but not this object open. This, for me, is a convenience decision. Now, you could, similarly, you could make yourself adhere to a strict policy of things that are X number of layers deep aren't bindings, they're only expressions or exports. I'm playing a little loose and fast with some of those rules. I think what I would tell you is that this is a place where you can start to think about, is this a binding or is this an expression? Up to you, dear programmer, to make the choice that you want to use there. Okay, let's add another text top. And let's also, while we're at the game of operators, add an out top. So we're adding an out because we're actually going to send some information out of this process. Now, what gives? I don't want to just stick just some random word. Not a random, love you derivative. Not just derivative's name right here, but what do I want to stick there? I actually want to put a whole bunch of additional debug information right there in that portion of my display. And I'm going to go ahead and I'm actually going to write a set of expressions in a table, and then we're going to convert those with an eval, and then that eval is going to further get converted. We're going to use a convert dat with that because we're going to change it from being a table to being text, and then we're going to end all this goodness, Alt-N, with the null called debug, and we'll scoot over our tops here because the contents of this stat are what are actually going to show up here as the information here. Nothing showing up now. What gives? Don't worry, it'll get there. Let's back up and write some expressions. Okay, I happen to know that I have 5 rows worth of expressions that I want to write. So I'm going to drop in 5 here. And I know that's only, 5 rows and 2 columns. That's what I'm working with. So I'm going to go ahead and set up my table for myself right away. And we're going to enter expression land. So the first thing I want to do is I want to put the name of this thing in here. And specifically, I want my grandparents' name. Now, out the gate, it's called projector, but we'll see later that this name, right, the name of the display is going to be something that's dynamically assembled. So I want to look for my parent to my grandparent, and its name. And what I don't want is I don't want this container business. I just want everything after that underscore. And a name in Python, we can think of that as a list. So I want to actually go 10 characters in, colon, and then go all the way to the end. Right? So this is 10 characters over from container past the underscore. So we only go from projector to the end. Okay. Next, I want to know the width. So I'm going to put that in quotes because it's got to be evaluated. I evaluate that as a string. What does that look like? That looks like my parent to my grandparents, width. And we'll notice right away, oh, that shows up as, it's got a decimal point. I don't want a decimal point for the size of my output display, because last time I checked, I don't get half pixels. I would like whole pixels, please. So let's just make sure that we cast this as an integer. So int, parentheses, open parentheses, and then we need a close parentheses at the end of this, and then make sure that we have just an integer value, whole number value. I want the same thing for height. I'm going to borrow this last expression that I wrote because I did all of that writing. Why not? And just make sure that I change this to .height. Cool. Now I did a sneaky thing for us at start. Already wrapped up into the project extension for this is something that grabs the host name of the computer and grabs the IP address of the computer. So let's go ahead and just grab that data right away. So I want IP address, and then how do I get that? Well, I put that in storage, and I put that in the storage of the project. So we can look at op.project.fetch. So I'm going to grab from storage the key that's called IP underscore address. That needs to be in quotation marks. There's a hidden local IP address for this particular computer on my network. And then I also want to know the host name. Okay, what's the host name for this here? This him, them, thar, here, goober. Op project.fetch. Again, I want the host name for this machine. All right, Vivian, that's this computer's name. We'll see that, all right, here our eval evaluates all that information. Our convert changes all of that from being a table into being a single, just a regular text stat. We've got our null, and then sure shooting, it's showing up over here in our text. Now this doesn't look quite right, so on the font page, I'm going to make sure my horizontal line is left, my vertical line is bottom, and then I'm going to give myself just a little bit of border space. I think I want more like 40 pixels worth of space on the left and right to bump that over there. Okay, so far, so good. Let's back out. All right, I like what we got here so far. We've got all this cool, swanky, lovely debug info that's handy for me to see right away. What do I do with this? What could it be?